In this video, we're going to talk about the reaction quotient, Q. So recall from our last lesson that the larger our value of K, our equilibrium constant, the reaction will favor the products more than the reactants, and the reaction will proceed farther to completion when equilibrium is reached. So we want to determine the position of where the system currently is with respect to the equilibrium, and we use Q. When Q is equal to K, the system is at equilibrium. When Q is greater than K, the system must shift towards the left, towards more reactants to reach equilibrium, because we have more products than reactants, so we need to go back to our reactants. If Q is less than K, the system must shift to the right towards the products to reach equilibrium, because the product is to reactant ratio is too low. We can do that with the following equations here. So in example 1, if the equilibrium concentrations at room temperature of the reversible reaction, for NO2 we have an amount, for N2O4 we have an amount. We are asked for our KEQ. So this is something that you would have done in the previous lesson. We know that it's always our products over our reactants, and since we have 2 of our nitrogen dioxide, we need to show that with raising our NO2 to the power of 2. The values that we are given, we can simply put in here. So we have 0.0724 divided by 0.0206 squared. When I do this on my calculator, I get 171. And I can check, I have 3 sig digs here. I'm responding with 3 sig digs. Try that value on your own. Now, if this reaction is taking place in a cylinder with a piston moved to half the volume of the reactant mixture, what's the new concentrations and the reactant quotient Q? Assume that the volume is now 0.5 liters. Okay, so when we're setting up Q, we keep everything the same as what we had for K. So Q, I'm also going to have N2O4, and I'm going to have NO2 to the power of 2. I did the math to change my new volume to 0.5, and I got the answer 85.3. So I want you to try that on your own and see if you get that answer. Okay, so since now we have Q less than K, that means that we're going to go towards the right, towards more products. In the next example, we're going to work through this here. We're given a value of KEQ. That's this here. If we place 0.5 moles of hydrogen gas, 8.3 moles of nitrogen gas, and 1.8 moles of NH3 into a 3-liter container, will N2 and H2 react to form more NH3? So this question is different than our equilibrium questions because it's asking us, will our reaction go towards the right or go towards the left now with this amount? So it's different. I, number 1, have to find my concentration of everything by taking the mole amount given to me and dividing it by the liters. I did that for hydrogen gas, nitrogen gas, and for NH3, 0.600 m. Now I have to put that into my Q. My products over my reactants I get 0.600 to the power of 2, 2.7 times 0.167 to the 3. This gives me 27.9. I compare this value to my K, which is 0.105, and I can see that Q is greater than my K. That means that my reaction will proceed to the left towards my reactants. And to answer the question, will more NH3 form? No, because I'm going towards my reactants. So we won't make more NH3. Again, we're using Q whenever we are looking at the direction, what will form more of when I'm given the values of what I have at my equilibrium. Try this on your own.